In this episode, we are going to build a beginner-friendly view of cloud computing by focusing on the characteristics that make it feel so useful and so different from older ways of running technology. Many new learners hear the word cloud and picture something vague, distant, and almost magical, as if systems and data simply float somewhere on the internet and become someone else's problem. That way of thinking leads to weak security judgment very quickly, because the cloud is not magic and it is not automatically safer or less safe than traditional computing. It is a style of delivering computing capability that changes how resources are created, reached, managed, scaled, and trusted. Those changes affect what people expect from security and what kinds of risk become more visible. Once you understand the characteristics that shape cloud environments, the security conversation becomes much clearer because you stop asking whether the cloud is good or bad in some general sense and start asking how its design changes exposure, responsibility, speed, and control. Before we continue, a quick note. This audio course is part of our companion study series. The first book is a detailed study guide that explains the exam and helps you prepare for it with confidence. The second is a Kindle-only ebook with 1,000 flashcards you can use on your mobile device or Kindle for quick review. You can find both at Cyber.Me in the Bare Metal Study Guide series. A helpful place to begin is with the idea that cloud computing is less about one specific location and more about a delivery model. Instead of thinking first about a server sitting in one company building under direct daily control, think about computing resources being provided in a way that feels more on demand, more service-oriented, and more reachable through networked management. That means the environment is often designed to let users or administrators request storage, processing, applications, or other capabilities without waiting for every single physical change to happen manually in front of them. This convenience shapes expectations immediately. People begin to expect speed, flexibility, and reduced friction because the cloud makes technology feel easier to obtain and adjust. Security must respond to that expectation carefully. When access to computing becomes fast and easy, access to risk can also become fast and easy if the environment is not designed with strong identity, oversight, and boundaries from the beginning. One major cloud characteristic is on-demand access to resources. In a traditional setting, adding new computing capability might require ordering equipment, waiting for setup, and coordinating several teams before anything becomes available. In a cloud environment, the expectation shifts toward rapid provisioning, which means resources can often be created or expanded quickly through management interfaces, service requests, or automation. This changes security because speed itself becomes part of the risk picture. When new systems, storage areas, databases, or services can appear quickly, the organization must make sure that protection appears just as quickly. Otherwise, cloud environments can fill with resources that were created for convenience, but never reviewed properly, never monitored carefully, or never retired cleanly when the original need ended. The cloud characteristic here is not only that resources are easy to get, it is that easy creation changes the pace at which security must think, because exposure can now grow far faster than in slower, hardware-driven environments. Another defining characteristic is broad network reach. Cloud services are typically designed to be accessed over networks rather than through direct physical presence near the equipment. That makes them powerful because users, administrators, applications, and automated processes can often reach the service from different places and at different times. It also means security can no longer rely heavily on the comforting idea that being inside one building or one internal network naturally makes a request safer. A cloud resource may be available to a remote employee, an automated business process, a mobile device, a partner integration, or a development team working across several locations. This broader reach changes security expectations because the boundary is no longer centered only on one physical office or data room. Identity, authentication, device condition, network path, and application-level controls become more important because the environment is designed to function across distance. A resource that can be reached from many places creates business flexibility, but it also creates more opportunities for misuse if trust is granted too casually. Resource pooling is another important characteristic because cloud environments often depend on shared underlying infrastructure rather than one isolated piece of hardware dedicated permanently to one single customer or one single task. This does not mean everyone sees each other's data or that separation is absent. It means the provider often uses shared physical foundations while enforcing logical separation between different customers, workloads, or uses. For beginners, this matters because it changes where trust lives. In traditional thinking, people may feel safer when they can point to a specific server and say that machine is ours alone. In cloud environments, security confidence often depends more on how effectively isolation, access control, and service design maintain boundaries on top of shared foundations. That means logical separation becomes just as important as physical separation, and sometimes more important in day-to-day practice. The risk is not simply that sharing exists. The risk is misunderstanding how much of cloud security depends on making shared infrastructure behave as though each customer's environment remains tightly separated and consistently controlled. Elasticity is one of the cloud characteristics that people often love most because it means resources can grow or shrink more easily as demand changes. If a business has more users, more data, more transactions, or a temporary surge in activity, the environment can often adjust more quickly than a fixed traditional setup. That flexibility is valuable, but it also shapes security expectations in subtle ways. When systems can expand rapidly, security controls must also be able to expand without losing consistency. If new instances, containers, storage volumes, or services appear during demand spikes, the organization cannot depend on slow manual review for every protective decision. The protections around identity, logging, segmentation, encryption, monitoring, and configuration have to be designed to scale with the environment rather than being added afterward one system at a time. Elasticity is therefore not only an operations advantage. It is a security design challenge because the environment can change size quickly, and every expansion creates another place where misconfiguration or missing control can quietly appear. Measured usage is another characteristic that shapes expectations and risk. Cloud services often track consumption in ways that are much more visible and much more directly tied to cost than many older internal environments. Storage, processing, data transfer, service calls, and other activities may all be counted and reflected in billing or service measurement. At first, this sounds like an operations or finance issue more than a security issue, but the connection is actually strong. Measurement means the environment leaves behind data about what is being used, how much is being consumed, and where unusual spikes may be happening. That can help with visibility and investigation when something abnormal occurs. At the same time, if an attacker misuses resources, automates abusive activity, or exploits a poorly controlled service, the impact may show up not only as technical disruption, but also as sudden unexpected cost. This changes the risk picture because misuse can produce both security damage and financial damage. The cloud characteristic of measured service therefore shapes expectations around visibility, accountability, and the need to watch resource behavior for signs of both compromise and poor control. Abstraction is another powerful cloud characteristic that beginners need to understand. In cloud environments, users and administrators often interact with services, interfaces, and logical resources without touching the underlying hardware directly or even knowing much about where it physically sits. That abstraction is useful because it simplifies work and allows people to focus on what they want the service to do rather than on every low-level detail underneath. The risk is that abstraction can make it easier to forget what still exists beneath the surface. There are still systems, storage devices, network paths, administrative layers, and dependencies involved, even if the customer does not manage all of them personally. Security expectations, therefore, need to stay grounded. You may not rack the server yourself, but identity still matters, configurations still matter, data still matters, and dependencies still matter. Abstraction can reduce operational burden, but it can also increase misunderstanding if people assume hidden infrastructure means hidden risk. Good cloud security thinking accepts the abstraction while still asking what parts remain visible, controllable, and accountable to the customer. Automation is closely tied to cloud computing and changes the risk landscape significantly. Cloud environments are often managed through templates, scripts, application programming interfaces, policies, and repeatable deployment methods that allow organizations to create and adjust resources at scale. This is powerful because well-designed automation can improve consistency, speed, and visibility. If security settings are built correctly into those automated patterns, then protection can appear more reliably across many resources than if people were making every decision manually from memory. The danger is that bad automation also scales very efficiently. A weak template, overly broad permission, or insecure default can be repeated across large parts of the environment much faster than in a more manual world. This means the cloud characteristic of automation shapes security expectations in both directions. It offers a path towards stronger consistency, but it also raises the stakes for getting the design right at the start. In cloud environments, one mistake in logic can spread farther and faster because the environment is built to repeat itself on purpose. Another characteristic that shapes cloud risk is service dependence. When an organization uses cloud computing, it often depends not only on its own choices, but also on the provider's availability, design decisions, maintenance practices, and supporting ecosystem. This does not mean the customer loses all control, but it does mean the control picture changes. A business may depend on provider identity features, storage behavior, geographic availability options, backup mechanisms, logging capabilities, or managed service safeguards in ways that were previously handled more directly in a self-operated environment. That changes expectations because the organization must think carefully about resilience, provider trust, and what happens when part of the service behaves unexpectedly or becomes unavailable. Security is not only about preventing unauthorized access. It is also about understanding dependency and planning around it. When an essential business function lives in the cloud, the provider relationship becomes part of the risk environment, and good security judgment includes knowing which assumptions are reasonable, which protections are built in, and which weaknesses still need customer attention. Geographic flexibility is another cloud characteristic that feels helpful operationally but important security-wise. Cloud resources may be distributed across regions, data centers, or availability areas in ways that support resilience, performance, and service continuity. That flexibility can improve reliability because the environment is less tied to one single location or one single point of physical failure. At the same time, location still matters. Data stored or processed in different geographic areas may be subject to different legal expectations, privacy considerations, contractual limits, or business sensitivities. Even without going deep into legal detail, a beginner should understand that the cloud does not erase the importance of place simply because access is remote and management is abstracted. If data moves across regions, or if backups and replicas live in multiple areas, the organization needs clear expectations about where information resides, how it is protected there, and what kinds of obligations or exposures come with that design. Geographic flexibility creates resilience opportunities, but it also means data location should be treated as a real security consideration rather than an invisible background detail. Multi-tenancy is another concept closely related to cloud characteristics, and it deserves clear treatment because it shapes how beginners think about trust. In many cloud services, different customers share a provider environment in some way while still expecting that their data, workloads, and activity remain separate and inaccessible to one another. This shared arrangement is a normal part of how cloud efficiency and scale are achieved, but it means isolation becomes absolutely critical. The environment must maintain strong boundaries so that one customer's actions do not expose another customer's information or interfere with another customer's service. For the customer using the cloud, this changes security expectations because assurance depends heavily on how well logical separation is designed and enforced. The risk is not that multi-tenancy exists by definition. The risk is failing to appreciate how important tenancy boundaries are to the entire security model. If people assume cloud means personal isolation in every physical sense, they may misunderstand where to focus their evaluation. In cloud environments, trust often depends on strong separation inside shared systems rather than on one customer owning every layer exclusively. Visibility is another area where cloud characteristics shape both opportunity and risk. On one hand, Cloud environments can provide rich logs, usage records, configuration views, and service-level insights that make monitoring and investigation easier when used well. On the other hand, the customer may not see everything happening underneath the service, especially in more abstracted offerings where much of the internal operation belongs to the provider. This means cloud security expectations must be realistic about both the strengths and limits of visibility. A team may gain excellent insight into identity activity, service configuration, resource creation, and data access, while still lacking direct access to some lower-level provider operations. That is not automatically a problem, but it does mean the organization has to know which visibility it truly has, which it lacks, and how it will make security decisions within that reality. The cloud changes the visibility model, and good security practice depends on avoiding two extremes: assuming you can see everything, or assuming you can see nothing worth using. A further characteristic worth understanding is the close relationship between cloud and identity. Because cloud resources are commonly reached through networked management, remote access, and service interfaces, identity often becomes the central gatekeeper rather than just one small part of a larger physical security model. A stolen credential, an overprivileged account, or a poorly controlled automation identity can create significant exposure because that identity may be able to create resources, access data, alter configurations, or connect services across large parts of the environment. This is why cloud risk is often shaped less by physical possession of equipment and more by who or what is trusted through digital identity. The cloud does not invent this problem, but it intensifies it by making so much control available through remote interfaces and application programming connections. Beginners should understand that strong cloud security often starts with strong identity design because the ease of cloud management depends on the system knowing who is asking, what they are allowed to do, and whether that permission still makes sense under current conditions. When you put these characteristics together, the biggest lesson is that cloud changes the shape of security expectations far more than it changes the basic goals of security. Organizations still care about protecting data, controlling access, maintaining availability, and reducing misuse. What changes is how those goals must be pursued in an environment that is more abstracted, more automated, more network reachable, more elastic, more shared underneath, and more dependent on strong identity and configuration discipline. Beginners sometimes ask whether the cloud is more secure or less secure than traditional environments, but that is usually the wrong starting question. A better question is how the characteristics of the cloud change the paths through which risk can appear and the controls through which risk can be reduced. Once that mindset becomes clear, cloud security stops feeling mysterious. It becomes a matter of understanding the delivery model well enough to know where trust should live, where assumptions should be challenged, and where control must keep pace with convenience. By the end of this discussion, the main idea should feel much more concrete than the word cloud often suggests at first. Cloud computing is shaped by characteristics such as on-demand access, broad network reach, pooled resources, elasticity, measured usage, abstraction, automation, service dependence, geographic flexibility, shared tenancy, and identity-centered control. Each of those characteristics creates business value, but each also changes what security should expect and what kinds of risk deserve more attention. The cloud is not simply someone else's computer, and it is not simply a faster version of traditional computing. It is an environment where convenience, scale, and abstraction can improve operations greatly, while also demanding stronger thinking about identity, configuration, visibility, boundaries, and dependency. When you understand those characteristics clearly, you are much better prepared to evaluate how cloud services affect security expectations and why risk in the cloud is best understood through design choices rather than through vague fear or blind confidence alone.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.